Let's do velocity time graph, please. Are we there? Definition, please. Velocity time graph is an aspect that helps to represent motion in a graph. An aspect that helps to represent motion in a graph. Velocity time graph is simply an aspect that helps what? Represent what? Motion in what? In a graph. Are we there? Comma. It is a graphical way at which we look for. It is a graphical way at which we look for the distance displacement of an object. It is a graphical way at which we look for the distance displacement of an object, comma. Are we there? Velocity of an object. Velocity of an object, comma, acceleration of an object, full stop. Acceleration of what? An object, full stop. Cast your mind back to SS1. If I have a graph this way, a Cartesian coordinates, I have my x-axis and what there? Y, Abi. What's my slope? No, we said a line like this, Abi, and I have this way, Abi. This is what? Change in y. Yes, what? Abi. I'm saying that change in y is what? Y2 minus what? Over what? S2 minus what? Apply the same technique here. How? We said when it comes to velocity time graph, I'm plotting velocity against what? Time. So instead of y and s, we come with the v and what? T. So for velocity time graph, I have a graph this way. This is your diagrammatic expression for velocity time graph. So here's what? T in second, Abi. Here's what? V in what? Meter per second. This is how your velocity time graph look like. Are we there? Now let's say I have a slope this way. Observe a line this way. Are we there? And a incline line this way. And I have let's say I have 2 points on this line. Abi, these 2 points will have different value of x and y's. How? Look at, if I have this way, this point has t. Let's call this what? T1, Abi. This one have what? V1. This same point will have that same another coordinate T2 and what? And V2. Abi, this one form what? A triangle. So that becomes what? The change in what? V over what? Change in what? T. Are we there? So because what there? We said that becomes change in V over what? Change in T equal to what? V2 minus what? V1 over what? T2 minus T1. Using the concept of that graph there. Are we there? So now, for me now, what do we observe? Observe, please. Change in y over change in t. Observe. Change in v over change in what? Will be equal to what? V2 is seen as what? As your v. Minus v1 is what? Initial. Are we there? That becomes what? The u over what? T minus t. T2 and T1. Well, at the time are the same thing. So let's say T2 minus T1 represents what? Just only T. So I have what there? Just T here. Abi, cast your mind back to your very first concept on physics when you do fundamental quantity and derived quantity. Also acceleration. At this point, recall that acceleration is what? The change in velocity over what? Over time. Abi now? And if I expand this, it becomes what there? V minus u over what? T. I'm seeing this stuff here. What does this signify is there? It signifies what? Acceleration, Abi. So this one now becomes what? A equal to what? V minus what? U over what? Over T. So what I'm saying here now is that note that the slope, put down please, put down, note please, put down, under this, put down, the slope of a velocity time graph The slope of a velocity time graph signifies the acceleration. Very important, please. Very, very important. At this point, note that the slope, observe please, the slope of a velocity time graph signifies what? The what? Acceleration. Very, very important. Are we there? That's the first thing to note. And look up, please. That's note number one, Abi. Note number two. That's number one. Note number two, N/B. Number two is that, are we there? The inclined line, observe, look up. This inclined line you're seeing represents acceleration, or perhaps signifies what the acceleration. The inclined line in a velocity time graph is the acceleration. Please notice very well. So if I look up, either slope or inclined line signifies what the acceleration, please. Now that's your first thing to note. Now let's look at some terms we use when it comes to velocity time graph. Let's look at basic terminology we'll be using in the study of velocity time graph. Let's start with this, please. So the first one is what? Acceleration. And I've showed you here, Abi, that when the inclined line is that's what? Acceleration, Abi, or the slope. That's number one. Number two, let me call number one here instead. Number two there is refers to number two, but here because what? One. Right? I should have shown you this one under this, but mind you, I've shown you that's gone. Let's now look at other terminologies, right? Number two is called constant velocity, or perhaps yes, just constant velocity. Put on, please. Are we there? Let's start with this, please. Let's understand what this means. Constant velocity simply means when velocity is constant. This simply means when what? Velocity is what? Constant. Abi? Therefore, acceleration is equal to 0. Therefore, acceleration is equal to what? 0. Are we there? Now listen up. Here's the thing. Whenever you hear the word constant velocity or yes, constant velocity, it means what? A is what? 0. Abi? Now, how do you express it? How do you express, for acceleration? I'll show you how to express in diagram, Abi. In two ways, Abi. How do I express constant velocity in a time graph? Here's it here. I'll have my V and what? And T, Abi. Here is V of T of M per seconds. Here's what? T of what? X, Abi. Now, if I hear the word constant velocity, how do I express it there? This is the expression. Say it's velocity, Abi, and this velocity here. So let me just speak a voice. Let's say this V1, Abi. So constant, this is a constant velocity. This line, straight line, it means what? Constant velocity. So when velocity constant, it's moving what? Just straight. It's not branching anywhere. Just moving what? Straight. It's said to be what there? Constant. Draw this man out, please. Draw it. Very important. Draw it. So yes, velocity is constant. It means that what? A is equal to what? A is 0. Please. So how do you express constant velocity? By what? Just showing what? It just is what? A straight line, as I showed you earlier now. Number two is called retardation or deceleration. Retardation or deceleration, please. Let's do retardation, and these two stuff are the same thing, right? Either I call it what? Retardation or what? Deceleration. What does it mean? Basically, retardation is simply an acceleration. Okay, put it this way. Retardation is simply a negative acceleration. Retardation is simply what there? A negative acceleration. It occurs when brake are applied to a moving vehicle. It occurs when brake are applied to a moving vehicle. I mean, mathematically, retardation, or if you want to call it what? Deceleration is equal to what? Negative acceleration, please. So know that whenever you have retardation, you should know that that is what? Negative. Question: if I ask you that the car move with a retardation of 5 meters per second square, is it 5 or minus 5? They will give you 5 in the question, but in terms of solving, you use what? A minus. Because I know what? Retardation, what? Deceleration. Now, how do you express this one in real time graph? How did it look like? I feel how constant for this to look like, Abi? Straight. How does I should look like? A what? Inclined line, Abi? How does retardation look like when it comes to real time graph? It looks I'm coming. All right, so I have this one. It's this form. Diagram of acceleration is this. This is your VRB, m per second. Here is TRB in second. If I have a line going down this way, it signifies what? Deceleration or what? Retardation. It occurs when a brake is applied to a what? Moving vehicle. So this is how you express retardation when it comes to this time graph. So here is what all you need to note when it comes to this time graph, please. One last thing to note on our whole, please. I'll start question, please. One last thing to note, please. One last thing to note, please. Are we there? One last thing to note. Are we there? Yes. Put down. If you are told to find, put down. If you are told to find the distance, if you are told to find the distance, are you there? Yes. In velocity time graph, if you are told to find the distance in velocity time graph, are you there? Yes. Open a bracket. Look for the area of the plane figure. Look for the what? Area of the what? Plane figure. Close a bracket. Are you there? Yes. Comma. The area of a plane figure of a velocity time graph is called the displacement or distance. The area of a plane figure of a velocity time graph is called what? It's called what there? A displacement or what? Or distance. So I'm saying that whenever you hear the word area of a plane shape, it means what? That's distance, or you call it what? Displacement. So I'm saying that the area of a plane figure of velocity time graph is called what there? Displacement or what? Or distance. So listen, in this topic, if you are told to calculate distance, what do you do there? Look for the area of that shape. That's all. That area is what signifies what the distance. So they're the same thing. Distance is a space between 2 points. While displacement is simply a distance traveling in a specific what? Direction. So distance is scalar. Displacement is what a vector. That's the concept. Example 1. Example 1. Let's do some price questions. So basically, I explained 3 things for you now. How to express acceleration in terms of what? Velocity time graph, Abi? Yes. How to express constant velocity, Abi? Yes. And also how to express what the retardation of what? Deceleration. So we said that one is what? A negative what? Acceleration. Example 1, please. Put down, please. Example 1. Example 1. Let's start with something easy. I'm coming, please. A car starts from rest. A car starts from rest Are we there? A car starts from rest and uniformly accelerates uniformly until it reaches a velocity of 30 meter per second. Until it reaches what? A velocity of what? 30 meter per second. Are we there? After 5 seconds, full stop. After 5 seconds, full stop. Are we there? Yes. It maintains the velocity reached. Please listen. That maintain velocity reached, what does it mean there? Constant what? That's the concept. Either use what? Maintain velocity reached or what? Use what? Constant velocity. That's the same thing. So it says it maintained the velocity reached for 15 seconds. It maintained the velocity reached for what? 15 seconds. Are we there? And it's brought to rest. That's what? Retardation. Brought to rest. Are we there? Yes. So, and it is brought to rest in 10 seconds with a uniform retardation. You can see that. With what? A uniform what there? Retardation. Determine question A. Determine question A. Determine question A. Are we there? The acceleration of the car, like A, underline A. Determine A, the acceleration of the car. Are we there? B, the retardation. B, the retardation. C, the distance covered in 5 seconds. I said A, the acceleration. B, the retardation. C, the distance covered in 5 seconds. Are we there? Question D, the total distance covered. The total distance covered. Final question. Question E. Are we there? Question E, the average velocity covered over the whole period. The average velocity covered over the whole period. Or perhaps the average velocity over the whole period. Full stop. All right, please. Let's get done, please. When it comes to solving problems under velocity type graph, your first things first is what? Draw out what? The graph. How does it look like? Now look up. What I know is that how this man look like is what? I'll have what? My what? V and what? And T as X, Abi? This is my what? V in what? Meter per second and what? My T, let's say T is here in what? Second, Abi? Question says a car starts from rest and accelerates. Please, how do I express accelerate? Accelerate. Incline is what? Acceleration. So accelerate, Abi, for what? 30 seconds. Sorry. Accelerate. I'm coming. Accelerate uniformly until it reach what? A velocity of what? So let's see 30 meters per second. 30 is here, Abi? Yes. This is 30. It reaches here. Yes. Are you there? Yes. Then I said after 5 seconds. So the time there is what? 5 seconds. Are we there? Yes. It then says what? It maintain a what? A constant velocity. Sorry, it maintain what? The velocity reached. Abi? Yes. Same thing as what? Constant what? Velocity. So all about like this, Abi? Yes. A straight line signifies what? Constant. I showed earlier. Yes. What next again? It says reach for what? 15 seconds. It said it maintained the velocity reached for what? So for me now, here's what? 15, Abi. But I won't put 15 here. It's 15. When we go to 15, Abi. But 150, all I put here, I will add up with this one. That becomes what there? 20.
Yes.
Instead of 15, I'll add up with the 5 here because of the a 20. Are you getting what I'm saying? What next again? It says, and it's brought to rest. That's what retardation, Abi. All look like come to rest. Abi? To rest in what? 10 seconds. So I'll not put 10 here. What will I put here? 30 out of 20. So I'll have what there? 30 what? Seconds here. Are we there? So with an uniform what retardation. So this is my what? Diagram. This is how the diagram look like. So this is my diagram for that question. I'm done with diagram. Let's get it done. What question one says? Say what?
Determine the acceleration of the car.
Acceleration. Let's start with A, please. Look up. Don't write. Let me finish. You're right. For A, all this to look for A. So the what? The acceleration of the car. Abi, that's your A. Now look up. Basically, what's acceleration? A is what? V minus what? U over what? Over T. Right? So look, this is find what the acceleration of the car. Abi, for acceleration, which one represents acceleration here? This or this? Which one? This line signifies acceleration. This one is what? Retardation. This one is what? Constant velocity. Abi, for the acceleration, what's V, what's U? This one is initial, is 0 here, Abi. So initial here is U, here is what? V. Abi? So my V is what? 30. So what's your V? 30 minus what? U is what? 0 over what? What's your T? For T, 5 seconds. Abi? So I have what there? 5 here. All I have here, 30 over 5. What's the answer, please? 6, Abi. 6 what? Meter per second square. Why? Acceleration. So my acceleration because what there? 6 meter per second square. I'm done. That's your A. Let's do B. What did B say fine? What did B say fine? The what? The what there? They shown, Abi. We said this man is still acceleration, but what? A negative acceleration. Abi? So have A is equal to what? B minus U over what? Over T. It's the same formula. Because it's acceleration, Abi. But I'm expecting what? A negative answer as my answer. Are we there? Now look up, please. In this diagram, which one illustrates retardation? This one, Abi?
Yes.
Abi? Yes. Please, when we in this way I get you and V, Abi. Where will V and U be here? Where will be U? Where will V? V be where? Down, Abi? Yes. Look, U will be here, V will be here. Before the body, look up. Initial means where it is before it start moving. Before this body start coming down, it was here initially. That's U. Before what? It goes down finally to what? To V. Are you there? So what's your V? What's your U per se? That's 30, Abi. So I'll be having V. What's V? Is 0 here. But now look up, Abi here. 0, Abi. Is 0 minus what's your U? 30. So I have 30 here. All over. What's your T? Observe. Oh, T is what?
No.
Is what?
30.
10. No, not 30. It's, no, when we're adding it up. Initially it was 10 before. So there's I get it. 30 minus 20 is what? 10, Abi. So my time is what? Is 10. Abi? So it means that A will be equal to what? Minus 30 over what? So what's your A? Minus 3 meter per second. It makes sense. Why? Retardation, a negative acceleration. We're done with this. What next there? The distance covered in what? 5 seconds. That's C. The what? Distance covered in what? 5 seconds. Please check. From here to here is 5 seconds, Abi. So here's what I'm doing now. When I say when it comes to calculate for distance, it's like look for what? The area of that shape, Abi. Look up for your 5 seconds. What does it look like? Triangle, Abi. Let me call here A, B, and C. Distance A, distance B, distance what? C, for instance, Abi. Are we there? So for my distance A, let me call it so distance, that's SA per se, Abi. What am I seeing there? A triangle. Abi, now I'm seeing a triangle here, right? So I'll have a triangle this way, a triangle this way. Are we there? So here will be what? 5 seconds, Abi. Here will be what? 30, exactly 30. So we said look for distance as if look for your area. So the triangle, what's the area of the triangle? So distance at A is equal to what? Half times base times height. Area of triangle, Abi. That becomes what the half times what's your base? That's your S. Abi. Or let's just put 5 straightforward. 5 times what? 30. What's my answer? So the distance at section A equal to what? Um now what do I have there?
75.
Okay, yeah, 75. 75 in what? In meters distance. So the distance covered at in 5 seconds is what? 75 meters. That's all. Look for the area. That's all. What's the last one there? Up as no? Okay. This what? Question this says what? It says the total distance covered from the beginning to the end. So look for what? Area of section 1, 2, and 3, like A, B, and C. So let's get it down. Let's get that down, please. It says the total what the distance covered. That's all true, Abi. Please check. I have section A, B, and C, Abi. Right? Look. Total distance covered is like look for area of each section. Section A, B, and C, Abi. But mine, I've done section A already. So the distance at A, that is SA, was what? 75 meters, Abi. Let's get SB and what? SC, Abi. So distance, so calculating for distance at what? At B, Abi. For your B, what are you seeing there? What shape are you seeing there? Rectangle,
Yes.
Abi.
Yes.
I'm saying what? Rectangle, Abi. Or you call it square if you want to. So I'm saying rectangle basically. So that becomes that rectangular shape this way, Abi. What is here? What will be here? 4. How?
15.
Like the time. No, this is the time now. This place, this is down here. Is the time. So what will time here? 20 minus what? 5 is what? 15. So I have 15 here. What will be the height here? 30. Abi?
Yes.
30. So what will be the area of triangle? So my SB becomes what there? Length times what? Breadth, Abi? What's my length there? 30 times 15. What's the answer there? What's the calculator?
30 times 15.
Yes, what you have there? Huh?
450.
For what there? 450. In what? In meters. Man, they say find what total distance, Abi. I've got for SA, Abi. I've got to what's next there? SC, Abi. And now what? Combine what? Everything together, Abi. So that's the concept. Okay, everything. Okay. Copy down. Hope you understand this stuff. So hold on, please. Hold on. Let's proceed, please. It says, question this says the total what distance cover, Abi, and I have how many distance there? A, B, and C, Abi. I've done for A initially from this one before. I just put my answer here, Abi. I've done for B now. What's B? 450, Abi. Let's get distance at section C. That's what? HC, Abi. Please, what for? Okay, let's put this way. Calculating for what? SC. And this is as section C, Abi. What be SC? What am I saying here? A triangle, Abi. So I have a triangle this way. So when it comes to find distance, it's likely for what? Area of triangle, area of a shape. The shape is what? Triangle, Abi. For me to what will be here? If here is 20, here is 30, what will be here? 10. Are you there?
Yes.
That'll be 10 here. What's the height here? 30. Abi? What's S of C? That's half times base times height. Half times what's your base there? Times how's the height there? All I have here 150. Am I correct? Meter. Abi? Confirm, please. Okay. So let's proceed, please. So I've gotten my distance at section A, B, and what? And C. What am I looking for? Total distance. So I'll combine what? All of them together. Do you get now? So it means that, so hence, so S of T, total distance will be equal to what? SA plus what? SB plus what? SC. Yeah. Proceed. You proceed. All right. So that becomes the total distance becomes what there? SA plus what? S plus what the XC. Are you writing this one? I don't have it. Let me just clean it up and put my answer there. So my answer becomes total distance S of T. What's SA?
75.
Check there. 75 Abi plus what's your SB?
150.
450 plus what's your HC? 150. Please add what do I have there? Total distance equal to what?
675.
6, 7 what? 5 what? Meters. So this is my answer. So when this says find total distance, Abi, total distance becomes what there? 675 meters. So total distance. Are we done? We still have E, Abi.
Yes.
E says what?
The average velocity. The average.
Velocity, Abi. What do you know? Average velocity, Abi, is that saying what? What velocity? What velocity? Displacement over time. Abi?
Yes.
So they're saying that total what? Total displacement, Abi? Over what? Total time, Abi? Total time. Are we there? Please check. What's my total displacement? Total distance is what?
675.
Displacement and distance are used here interchangeably. I can call it displacement or distance. They are not the same, but I can use them here, vice versa. We don't get now. So what's my answer here? 675 over total. What's total time? Total time is what? Is 30. 30, Abi? 30. Because I'm adding it up when I was doing it. So that's 30. What's my answer there? 20 point.
22.5.
All right, 22 point what? 5, Abi? In what? Meter per second. Why? Velocity. So my VA, average velocity, is what there? 22.5 meter per what there? Per second. Please, that's all. That's how you solve this particular problem. We'll look at yet another example and see what we get.